Hello, everyone. Hello, Dave Glover. Welcome to the Azure channel. We
Hi
are
there.
very glad to have you here.
Thanks very much, Jorge. Delighted to be here. We're in the same team. Funny enough, we've actually kind of never worked together before, have we? So this is our first chance to go and do a podcast together.
That's true. That's true. That's all my pleasure to have you here. And we are both playing for a couple of days on the new Windows Dev Kit desktop using ARM64 architecture. And that's what we're going to, come today and try to show a little bit of fun and that we're having on those couple of days. And a lot of people from the community talk about the dev kit, Windows Dev Kit. How do you see that? Are you excited?
Fingers crossed. Fingers crossed. People are been checking it out, and want to try it out. And we're both of us were kind of developers, infrastructure people, AI. So I think we've fired up a whole lot of scenarios, which hopefully cover off. Not going to cover off everything, but kind of give everybody a bit of a sense of how it's playing out and how it's working and some of the things we've struck along while we've been setting things up and trying it out. So yeah,
That sounds good. Sounds good. Let me just. I
actually we should
think I have
probably
a couple of pictures here of the
oh,
product.
while you're starting up, I should actually say that we're both in the cloud advocacy team. Though we're in slightly different teams. So I'm based in Sydney, and I've kind of had a focus on IoT devices, intelligent edge, and nowadays I live in the data and AI team. So really kind of doing much more focus around AI, cognitive services, things like that. But fundamentally, I'm a developer. That's kind of where I kind of land.
Yeah, it's good for people to know. I'm also on the cloud developer advocate team, but on the cloud native containers Kubernetes side. And I'm also come from development, have done a lot of .NET development in the past, Java, C++, Delphi, a lot of different languages over the years. All kind of developers in the heart. And
Yeah,
what I'm enjoying is like that. That's my desk. I just took some pictures and I have the dev kit on the left side. And that's, I see, the power 90 watts power supply for that. And I'm also using my dock station, a Targus dock station. Then I have a couple of monitors. I'm going to be able to see my monitors here. Um, the device itself, if you want to comment, Dave, like three USBs, a mini display
yeah,
port, networking, like gigabyte network. And
yeah. So it's got
there's
it's
another
a
one that,
I guess the important thing about it is that the target market for this is a bit in the name. Although Microsoft has this wonderful ability to create really complex names. So it's called the Windows Developer Kit 2023. And the target audience for this really is developers. And it's got a decent developer spec on it. So it's got good amount of memory. So it's got 32 gigs of RAM. It's got 512 gigabytes of SSD. It's got an NPU in it, so a neural processing unit in it, which is actually pretty decent. Not that, unfortunately, I would have liked to have done demo today for the neural processing unit, but that might have to wait to another day. But it's a highly capable neural processing network on it. But so the important thing about it is it's targeted developers, and what it's really trying to address in the market is we want to kind of build momentum around Windows and apps on ARM, but developers at the same time say to us, well, we've got nothing to test it on, or what is out in the marketplace is just not appropriate. So that's what this device is about. It's bringing out a device that's suitable for developers to go and port across their applications from typically from Intel technology, Intel x86 or x64, and bring it across to ARM. So that's kind of why the device exists. It's out there for developers to kickstart their migration. So you're getting all my pop-ups.
Yeah, that
So
sounds
yeah,
good.
that's
I'm very excited. Very excited, to play with that. I can share your screen here if you want. If you want to start showing there,
yeah.
let
Okay, sure.
me let me jump your screen there. And is
Yep.
that the
Okay.
correct
Cool.
one? Yeah,
Yeah, that's the right one. Okay.
yeah,
So what I've done here. So this is an ARM device. If I go click over here. If you're not familiar with ARM, it's a technology that's been around since the 80s. And the compelling reason why people like ARM is because of its low energy usage. And that translates to lower cost, lower power consumption, longer battery life. Those are kind of the reasons. And if you've got to kind of think about green issues, then obviously consuming less power is always a good thing. So this box here, it's running the Snapdragon compute platform 3 gigahertz. It's what's called a Gen 2 device. And so on this device, I've got pretty much all the things that I would kind of use for development. So the first one here is that there is now a native version of Visual Studio 2022. It's in preview, so hopefully soon to come out of preview. But it's very performant. Though I've actually already opened it. If I go and run up another instance of it, you'll see it actually starts up pretty much instantly. We can go in there and we can get into Visual Studio. So it performs very well. It's natively compiled for arm64 and it runs very well. And what I've got in here is it's a WPF app. And as I mentioned before, one of the things we're trying to encourage developers is to take the existing applications and port them across and test them and then publish them out as arm64 apps. And you can see here, if I go and put in I'll just go and run this app up, and you'll see it goes and kicks off the build and fires up the app. And you can see it actually starts up pretty quickly. I think I probably had done a previous build on it just to check before the demo, but you can see the app is running very smoothly indeed. So that's one of the things you'll notice, that once you start using this, it's a very good environment, performant environment. This is actually probably one of the first ARM chips that I've been using, what Windows runs on, that I'm using kind of as my daily driver. The performance is decent enough that I can be productive on it without feeling like I need to go back to my other machine. So that's kind of building a desktop app. And if you're doing any cloud development, you're probably familiar with Azure Functions. And this is just going to kick off an Azure function. And I literally went and created that before. And it shouldn't take too long to start up. Hopefully, did I go and close something down? Oh, there we go. Fired up. We're going to click on the endpoint for that function. You'll see it hits the breakpoint. I just put a breakpoint in there just to say you can step through your code. So all the kinds of things you'd expect for the environment works pretty well. I know these are pretty straightforward apps. If I go and put in name equals Dave, and I'm sure you've played around with a skeleton version of an Azure function, just using the HTTP trigger. So those are things that are going on there with Visual Studio 2022 up and running on ARM, and it's a really good experience. Now, clearly, I'm using relatively small apps in here, and I'm going to show you a bigger app that I'm going to compile shortly. The other thing that I do, go for it.
Yeah, like I'm also having a very nice experience doing Visual Studio, like full Visual Studio deployment. Running on. You can use IS Express, you can use WSL, you can use hot reloads. And I noticed that you have like the full .NET framework available now for 8.1, I think, for ARM64. I think that's amazing.
That's right.
A
yep.
native.
So there's so full fat .NET framework. I think it's 4.8, 4.81 or something along those lines.
Yep.
And then of course there's .NET 6, .NET 7, what we might have used to have called .NET Core, but we're kind of converging in the naming. So that's 6 and 7 are also 7's currently in preview, but they're natively compiled for ARM. So again, highly performant. Yeah.
That sounds good. That people can get the application, even legacy application, and maybe recompile and see how they can have a ARM64 version now that we have all those devices available.
Yeah, exactly. So the other thing that you almost invariably do, and I'm just going to show you one of the apps I use on here. I write a lot of my documentation in using Docusaurus, which is a static website generator. It uses nodejs to go and build it. So you can see now Node is actually an x64 app, but there is translation in there from x64 to ARM. So that just kind of happens under the covers. And you'll see it's building my static website and compiling that up. And in a moment, it'll throw up the website. And there goes my static web app. So you can see that's kind of running Node. Pretty straightforward. There is ARM versions of Python. So I think it's Python 3.11. There's actually, interesting enough, a native builds for Rust. So there is an ARM64 implementation for Rust as well. Most of Rust is there. I think Rust up, I think you can just still as an x64 application, but that's a fair amount of there. So what else have I got installed on here? I made some notes, obviously .NET, Visual Studio. Visual Studio Code is natively compiled for Windows on ARM64. So that's a good experience. As you can see, it's running on here. So those are kind of the main things that I was kind of showing for Rich Desktop development. Now, of course, it's not, I've shown you some simple apps. It's also important, and this is kind of one of the drives behind this, is to figure out what needs to be ported across. So, for example, I was doing some stuff on Python, and I found some Python libraries don't build on Windows and ARM. So there are issues, but the way I kind of worked my way around that, as I said, I bet you this installs on Linux on WSL. So I went and installed the same application on Linux and WSL, and yep, all the libraries installed. So the beauty of that, of course, is you're not going to be stranded. There's a lot of stuff out there which is built out there for Linux, and you can use those really happily on WSL as well. So yeah, it's kind of nice. I think there's some things that you want to show one day, Jorge.
Yes, I was going to say about .NET 7. They improved the performance of ARM64, means that they are promising the same performance as the full .NET on x64. I haven't tested it, but the numbers and the metrics that they're showing is very good. Means that recompile using .NET 7, if you already have your product on ARM64, will be nice because you're going to get a better performance.
Yeah, should be pretty straightforward as well. Yeah.
And you're probably going to see, Dave, even the applications that we are developing in .NET, we're going to start recompiling .NET 7 probably soon, and you're going to see performance improvement, I think, on our products itself that are developing .NET.
Yeah, the .NET guys are, particularly the last couple of generations, have done a really good job of improving performance. So obviously the beauty of that is that you don't have to do any work, and you just kind of inherit that performance work that we're doing under the covers with .NET framework. So that's very nice. Yep. Yeah.
Sounds good.
So I've got a couple more demos. Or do you want to switch over to you, talk a bit about what you've got running there, or I can carry on, or what do you want me to do?
I can show WSL a little bit if you want. Let me jump in here before you go to. Or you want to compile? If you want to compile your code first, I think it's a nice. Let's go compile your code.
Because one of the things that you see a lot of demos is thinking, oh, what's really going on here? And this is an app. It's compiling about 100,000 lines of C code. So this is my GitHub repo. So I'm Gloveboxes on that repo. And I've got a neat project which is called the Altair. So Jorge and myself, I think we both have an interest in retro computing. And this is actually the source code to go and build an Altair. So it's using the software stack. It's actually running an Intel 8080 software emulator And they were running that and building that, and then we're compiling that and running that on an ARM device. So this is the project. It's sitting up there on my GitHub. And so it's about 100,000 lines. And if we just go and rerun that, so the first thing we're going to do is I'm just going to delete out the build. So it's kind of starting off from fresh. And it's probably going to prompt, oh, I should go and make that for 8 cores. Put my password because it wants to do that sudo remove recurse. And goes and builds a CMake. And then you'll see, as I said, this is building about 100,000 lines of code, and off we're going. And you can see that's a pretty decent performance there for going off and building a pretty decent sized application. And then you can see I can go and do build. That's the emulator. And you can see it's now running on the device. I can go and bring up the web terminal for it. And I can connect to it. And hey, look, I can go and run the weather or something like that, goes and grabs the weather. So that's the kind of thing you can see there. So it's a decent size app that is being compiled, and you can see that the performance is pretty good. I've compared it with other ARM platforms out there, so obviously from the likes of Apple and Co, and the performance is very similar. It's very similar. I think my Mac Mini, I think, was probably about a second ahead. But in the scheme of things, neither here nor there in terms of overall performance and for building these apps. So yes, there will be, I guess, benchmarks out there, but really for what you want to be able to do and build on this platform, for the amount of memory you've got, footprint, all those kind of things, you can do a lot of things. The other thing that I've got running in WSL, I mentioned before, I just thought I'm going to play around with Jupyter Notebook and just see how that works. And I tried installing some of those libraries on Windows, and as I mentioned before, I did come unstuck. And so I went and installed them into WSL, and it worked really well. So now I've got inside my browser, where is it? I guess something over here. This is my Jupyter Notebook running here, and we're just going to do the usual kind of thing: start, run, and hopefully that should. And you'll see that I actually found was pretty decent. What this is doing, it's I've got about 15,000 data points that have come off an IoT device. And in that space of running that, they were shipped up. I shipped the data set up onto Azure Blob Storage. And then I called something called Azure Anomaly Detector. And then what that did, so you can see the data, there gives a bit of a snapshot of the data. And then what it does is it figures out where the anomalies are in that data set and then pulls it back and graphs it. So that's kind of what that's doing. So it's a real world app. And I was extremely pleasantly surprised and pleased just how well it was running on the ARM. So it's running Ubuntu. I'm running Ubuntu 20.4 arm64. So it was very pleased to see just how well that worked. I think those are the main things. Oh, actually, no, while I'm here, and so rather than jumping around screens, one of the other things, of course, is that there is support for graphical apps inside Linux. So, for example, everyone's favorite kind of open source Photoshop equivalent, which is GIMP. Hopefully that'll start up in a moment. It's taking a little bit longer than I expected it. Of course, now we're going live and it's decided it's not going to work. Let's try something else. Of course, Sod's Law would say it's not going to work. I'm not entirely sure why it's decided it's not going to work, but let's just close it out.
I think you have Firefox open and GIMP is already open there. That's why.
Maybe we'll give that a fire up. No, I think it's got itself. We'll try.
I can show from mine here if you want.
Yeah, show from yours. The joys of doing a demo, and I think, oh, I'm just going to show this. And of course, it's going to happen. Now, actually, before we switch over screens, we were just talking about something before, and I just wanted to go back. So this is the main blog site for the announcement of the Windows Dev Kit. Excuse me. So one of the things that a number of people have picked up on is that you'll notice that there is a mini display adapter on it. And there's a couple of USB-C. So you can actually have up to 3 displays on this device. And I think a few people have been caught out by this, is that you say, oh, yep, I've got a mini display port to HDMI adapter sitting in the cupboard somewhere that I haven't dragged out for a long time, and I'm probably using HDMI on my other machine. I'm going to use that and plug it in. And you're kind of struck that it doesn't work. And you're thinking, heck, why doesn't it work? And one of the important things is to scroll down just a little bit further down here and look a bit in the fine print. And the fine print says down here is that you need to have an active mini DisplayPort adapter. Now, Jorge and I were talking a moment ago and said, what is an active mini DisplayPort? And I have to confess that I don't think either of us knew, other than we needed one. And so I just went up and bought mine up on Amazon. You find them lots of places, of course. But just keep in mind that if you're thinking, great, I've got an HDMI cable, got my screen, plug it in to this mini DisplayPort adapter I've had sitting around for a long time, and you're wondering why it doesn't work, it won't work because it must be an active one. So that was just something that I've just seen a few people get caught out on this, who are doing reviews on these. I think, Jorge, you might have got caught on this as well, I suspect.
Yeah, I got caught, and then I say, well, I can't see anything, and I was trying different connectors.
Yes.
Then
Yeah, so it
finally
can be a
got
bit
my USB-C and works.
Yeah, and the other trick with if you do it from USB-C, which is what I did the first time, you turn the device on, you think, heck, has it started? And of course it's quiet, doesn't make any noise. But it takes, because you're not got the micro display port on, you're not seeing the boot screen. But when the device starts up, then the USB-C display driver starts up, and then you'll start seeing the traffic, display traffic coming through the USB-C onto display. So that was another thing that I kind of got caught out thinking, heck, I'm sure it's turned on, the light's on, kind of what's going on. So those are a couple of tricks and things that I got caught out on. But yeah, do you want to flick over?
Some people said that takes 25 seconds. That's exactly because when the display shows from USB-C, pretty much the Windows is already running, everything's running. You have just to log in. And I think that's the main reason.
Yeah.
Why it take so long. You cannot only see, but it's already there.
Yeah. But certainly waking from sleep, it's pretty much instant.
And if you please sleep.
Yeah, and it supports connected standby and all those kinds of things that you'd expect. So, yeah.
Yeah, that's a lot of information, Dave, and thanks for preparing and doing that in 2 days. We just got the device and we jump on that.
Actually,
we're both very happy to order on the first day.
Yes, we're both excited. We both like gadgets. Why don't you do a demo, and then we'll flick back to my screen and we'll talk a bit about Hyper-V.
Okay,
and
let's do it.
And we'll just show what.
Just remove that one from here. Yeah, that's me. I'm also Jorge Arteiro, my GitHub. You can find that I even played a long time ago with Blazor Desktop, and some people keep liking this repo. That was just like a play. And you notice that I have a lot of things running here at the moment. And you see like 85% CPU. Memory is fine. There's plenty of memory on this machine. But I'm running all the broadcasts for this recording from here, Dave. Means that I have like StreamYard running with local processing. You can see that my GPU 25% on my browser because StreamYard is running from there. You can see StreamYard getting some load there in GPU process. But I also have WSL, Windows Subsystem for Linux, with Docker and also with Kubernetes running. I have a Kubernetes cluster running. And you can see my memory being used, 3.5 gig for WSL, where Docker and Kubernetes are running there. And then if I scroll down and I do Docker PS, you can see my Docker containers, Docker image, then Docker is running. I think that's the first thing I want to show is how to install WSL. And many people don't know how to install, and the easy way now to install the latest version of WSL, and we recommend you just go on the Windows Store, search for Linux, and then jump on that Windows Subsystem for Linux preview and install that preview. Why? Because this one you have the latest version, including like systemd support, and that's the version that we recommend you to install. Once you install that, you can pick one distribution to install. I have installed myself 2204 Ubuntu. Then after that installation, you're going to create your account, and you're going to log in on your Ubuntu account. And as you can see, I have systemd running, and Snap is the package management now for Ubuntu. And I have all these things installed, like including Firefox. And I can prove that systemd is running. There you go. You have all the systemd starting all the process for you. Means that if I stop this and start again, I don't have to manually start up Docker anymore. All the processes are going to be managed by systemd. And systemd, you can see systemd configuration on this file called wslconfig, where there is an option that you can set systemd true. And all that documentation, there is a nice blog post explaining how you can use like systemd. Craig published this explaining how systemd is available since like last month. A little bit more than a month ago was made available. But you can also install WSL from GitHub if you want. If you want the latest version, Dave, like us, and you're a developer and you say, I want a pre-release, you can get the latest, or you can get the latest. This latest here will be the one from the Windows Store, but you can also get a pre-release if you want. Just download from here and install. As you can see, there is arm64 available as well. And WSL runs as arm64 process. I think you can see all the architecture on the process here, and you're going to see that WSL itself is running as full arm64 build, like a native arm64. That's WSL. Then once you get WSL running, people ask me, how can I install? Not many people have managed to have, Docker install, Dave. And the easy way is using Snap. You can just create a group for Docker, set your user to be part of this group. Why? Because you don't want to use sudo all the time when you run Docker commands, and then you run Snap install Docker, and everything will be there. As you can see on my Snap, I think it's on the previous screen, I have Docker installed using Snap. Then once Docker is installed, you need like a couple of command line tools to be able to create a Kubernetes cluster. One is called K3D, is like Kubernetes using Docker. And they're also using, K3S, and you need the kubectl command line by itself. And if you remove that one, you can see the full command. Once you have both command lines, you can just use K3D cluster create, and then you have a full cluster running.
So with one line of code, you basically
one line of code, and you have
right.
these running. And let me show the K. If you never saw K3D, that's it. K3D cluster, I think it's list. There you go. You have a cluster running. And if you want to check the cluster, just check the nodes. There you go. You have one node cluster.
Yeah.
And Visual Studio also works, the Kubernetes extension. I'm using Visual Studio code running inside WSL. You can see here. And I install a couple of extensions. Those are the Kubernetes and Docker extensions. And there you go. I can see my deployments running.
So when you built those, the images that go into the pods, they're going to be arm64, aren't they?
They have to be arm64. See, this one I cannot show running because it's failing to download the image, I think, from my registry.
Right. Yeah.
But yeah, it has to be arm64. This one here is. Those images has to be arm64. And then also, you can say the Docker extension, you have a couple of containers. As K3D, they pretty much run a full Kubernetes cluster inside a single Docker container. That's how that works.
Right. And correct me if I'm wrong, but you can you can now go and create a virtual machine in Azure in the cloud, can't you? Using arm64. I think it's called Ampere or something along those lines.
On Azure, you mean?
Yeah, on Azure. Yeah.
Yeah, you can create a full Linux VM using the same one that you can also create a Kubernetes node pool, like a AKS, Azure Kubernetes Service node pool using ARM.
Yeah.
And yeah, you'll be similar to that, but you can deploy on Azure Kubernetes Service, and you can mix Linux, ARM64, Windows, and even WebAssembly on Azure Kubernetes Service. You have all these 4 architectures available. WebAssembly is a little bit not like architecture, but we kind of integrate WebAssembly on Azure Kubernetes Service now. Then you have Windows, Linux, ARM64, and WebAssembly.
Okay. Wow. Okay.
But there you go. You have now a full Kubernetes cluster running. You can get all the service running inside the cluster. As you can see, it's a normal K3D cluster with traffic ingress controller. If you get this IP number from here, and you open, I'm going to open on Firefox. That's Firefox running on WSL. There you go, mine works. And as you can see, 404, just because I haven't deployed anything on this ingress.
Right.
But this is Firefox running inside WSL, Windows WSLG, and opening like application running inside the Kubernetes clusters that's running inside Docker.
Fantastic.
There's a lot of layers there.
Lots of stuff, and it performs incredibly well. The way that you can sometimes get a bit lost in it, and if you look at the close app icon and minimize and maximize, you get a slightly different look and feel to them, haven't they? And that's kind of how you can tell that. Okay, I'm using the Linux version, but you can install Microsoft Edge browser into WSL and run it from there too if you fancy. So you can do lots of kind of interesting combinations of mixing.
I did install Firefox, but you can install Edge and pretty much running everything from Linux. This browser is not running on Windows, and running inside the Linux WSL.
Yeah,
it's a lot of things running here, and I also have Visual Studio, Teams, all the Office, everything running as native application.
Yeah. And actually that's the kind of thing I want to talk about as well, because there's been a huge investment from the Windows team, because a lot of us have been looking at Windows on ARM for a while, thinking, what's going on with it? But there's been a real push of recent to get all this up and running and working really well.
If you go in details, you can see that pretty much everything is ARM. Look at this.
Yeah.
It's only like a few that are like x64. That doesn't make much difference for us. I can see that Intune still needs some work on that. And by the way, this machine is all fully connected with my Microsoft domain. It's fully joined to the domain, using Intune, like joined to Intune. The device is actually on Intune. And I'm fully connected here. I'm using my Bluetooth for my iPod Pros I have the iPod Pros here connected. It's pretty much similar as my laptop, to be honest. I haven't noticed any difference yet. It's very quiet. It's quieter than my laptop. I can even hear anything.
Yeah.
I'm really enjoying, and I can hide this box anywhere here under my. I have this extension for my laptop. It's kind of, I can just hide under that.
It's got
Then
multiple cores.
multiple cores in there. Yeah, that's it. That's what I have to show. And I feel like Windows 11, I don't feel any different to be ARM64 so far. But I'm pretty sure that the performance is going to keep improving next few months.
Yeah, definitely. There's definitely work to be done. And this is it's a developer release, and there's still work to be done. If you flick back to my screen.
Yeah, there you go.
So what I've got here, I said I'd just talk about Hyper-V. So I've got a couple of Hyper-V. So Hyper-V support has been on Windows ARM now, I think someone mentioned, since about June. So it's been there for a while. I'm running Hyper-V, so you can see I've got an Ubuntu image over here. So I'm just running NeoFetch. And you can see that I'm on Ubuntu 20.20.04 is what I've got installed, .1. And you can see that the architecture is 64. So if you look in the main screen there. And that kind of performs as you'd expect. I don't think I enabled Docker, but if I go and do Docker run and hello world, put password in, and there you go. There goes hello world running inside a Hyper-V virtual machine, running on Windows ARM, running in an ARM-based Ubuntu image. Now, so which is like, again, we talked about lots of layers going on. There's a lot of investment to get all this up and running. So you can see that there's an awful lot you can do. Next thing I want to talk about is just running. It's often quite useful to go and run a Windows 11 image or virtual machine inside Hyper-V. You might want to hack on some tools, and you don't want to break or potentially break what's installed there. So you can see I've got Windows 11 loaded up there inside a virtual machine as well. And I'll explain a bit about how I did this. Now, the first time you do this, in fact, what really happens, let me just switch across. This is actually the default experience, and it can be slightly frustrating. So what's going on here is that this is called enhanced, something like enhanced connection mode or enhanced connectivity mode or something along those lines, for the connection into the Windows 11. And you start thinking, why the heck can't control enter, and I control delete enter, and I can't put in my PIN or my password. What's the way around this? And the way that I remember that I did this ages ago, and it's been a while since I've done this, but you come up there, you see a little icon just kind of floating around in the menu there. You convert it across to a basic session, and then you can magically sign in to your Windows. So that's the trick. You've got to flick it across to basic mode to be able to get into your virtual machine. Now, I just want to talk a bit about how I actually installed Windows 11, because you might be thinking, well, how did I do that? So obviously you can download the image. But the way I did, actually, no, you can't just download the image. You can't just go across to Visual Studio if you've got a subscription and download the image. Now, amongst one of these tabs, I think this is the right tab here. If you go searching for Windows Inside Preview Downloads, and you go through there, and the way that you can do this is you go and select the build that you want. So you can go either the beta channel or the dev channel. So we go, we'll go for the beta channel, click on confirm, and then you get the option, I think there's only English US, click on confirm, and that will download the image for you. Now, I've already downloaded it, so I'm not going to go and make you all suffer while we're doing that. So the way that you go and use that image, so the image that came down is a VHX. So what's this? A VHDX. So it's an extended virtual hard disk format. And the way you use those inside Hyper-V is you come over here into Hyper-V Management Console, and you go click on Quick Create. And now the really tempting thing, if you've done this on Intel technology before, is to think, look at that. I've got 5 5 images there I can just go and download. Couldn't be easier. Unfortunately, those are still the Intel x64, AMD 64 images, so they're not going to work. So what you do is you click on the button down here which says local install source, and you go and change the instance source. And in this case here, I just go across to my downloads directory, go and click on that VHDX. You can come down here, and I think you just say there are more options. You can come in there and say, hey, look, this is my Windows, not my Windows. I always type that for some reason. Windows 11, I don't know, number 2. This I've already got an instance up there. If we just go and call that. And what switch you're going to use. And it's as simple as that. Go click on create a virtual machine, and you're off to the races. And then it will go and build that virtual machine from that VHD disk, extended disk. And it took me a couple of minutes. So you'll see it goes through this. I think it goes up to about 30% and then races off just like that. And we're going to click on connect, start it up, and you can see that we've got another instance of Windows 11. I probably just don't have enough memory. Yeah, I thought that might be pushing things. So I've got too much. I've got too many virtual machines given the amount of memory that I've got. But anyway, really straightforward to get a virtual machine up and running. For the Ubuntu, I just literally went up to ubuntu.com and I downloaded the ARM image and installed that. Just grabbed the ISO, fired it up, did business as usual for setting up a virtual machine, and really straightforward. So a lot of support on there if you want to go and do something and do some testing and virtual machines on Windows ARM as well. So you've got WSL, you've got Hyper-V, you've got virtual machines, you've got the developer tools. Jorge mentioned that you've got productivity tools, so Office, Outlook, PowerPoint, all those types of things, all now native ARM. A lot of the developer tools are over there on ARM. The thing that, again, we're really hoping that if you're a developer and you've got libraries out there, that you get on board with this. The devices are expensive, and you look at your libraries, you test your libraries on Windows and ARM, make sure they work, publish them, and then people who are using those libraries can come along with confidence that they're going to work on ARM, and everyone kind of gets the benefit. So we've got more choice out there. You can got Intel, you've got AMD, and you've got ARM-based devices out there as well. So lots of choice, and ARM is definitely very much the flavor of the month at the moment, particularly around low energy usage. So those kind of things to think about. So yeah.
Yeah, sounds very good. I'm really excited, to be honest. We managed to in a couple of days have everything working and the whole environment. We tested so many things in just a couple of days, and I haven't, I'm not feeling missing anything. Pretty much everything that I need for my daily base. That's I do a lot of containers and Kubernetes. I need WSL, and WSL with SysND latest version, everything works fine.
Yeah.
We're giving some feedback for the team, and if you find something that you want to let us know, just leave a comment here, ping me on Twitter. We have both Twitters here on the screen, and let us know that we can work with the team and try to fix that as soon as possible.
Yeah. Actually, there is something that we've both spotted, isn't there? We might as well raise it here because you're probably going to strike it. We've noticed with WSL, when you fire it up, it seems to be looking like it's using one of the CPUs kind of full throttle. So you'll see it kind of bouncing along and thinking, hang about, I'm not doing any work. Why is my CPU being utilized at around about 36%? I think I've seen mine hovering at. It's certainly an issue that was spotted, and we have flagged it up. So you will spot issues without a doubt. Some of this is pretty fresh. It's actually an issue that I think has been floating around on Intel and AMD for a while as well. So just keep that in mind. You might spot that. You might be scratching your head thinking, why is it going on like that? I thought the guys said it just worked. And it does pretty much just work, but there are definitely some niggles in places.
Yeah, I agree. And there'll be, having this device is going to even push us more, to improve those things even more. And have more people jumping on board of arm64. That's going to be, I think, the main reason for us to keep improving. And I'm excited so far. but I'm also expecting more. And well, on my side, on the containers, I think you can start now. You pretty much have what you need. Everything I was doing on my Intel laptop, I can do it on arm64 as well. And I have 32 gig for $599 US. I think is quite good.
Yeah, that's a very, very good deal. I think about this machine that's running on my desktop. I think it's choose around about 6 watts. I think it's on that kind of. I looked at the amount of power that gets pulled from my. I've got an AMD 5900X. I think it's drawing about 105 watts at peak usage. So great way to save power bills, and obviously do this en masse, and together we can actually save an awful lot of energy worldwide, and we kind of need to do that. So
and for web development, like for developing in general, you don't need much CPU, you need more memory sometimes. Like in Kubernetes, you need a lot of memory, because if you want to do like some things locally. And 32 gig is very nice to play with Kubernetes. Once we fix this issue with CPU on WSL that we just found, then CPU is not going to be a problem to do all your development locally, to be honest, with 32 gig of memory for $599. I think is a good deal. We can bring more developers on board and on the containers that we need, more resource, or just create a Linux VM on Azure, and you just pay when you be running there. I think we have so many options, Dave. You can play with code space. You have
exactly.
We have Azure VMs. You have device. It's nice to have options.
Yeah, and we kind of talked about this up the front. One of the things, and I would have loved to have shown it today, but it turned out to be a little bit more complicated than I thought, which is getting the NPU up and running. And NPUs, the amazing, if you're not familiar with it, it's a neural processing network, neural processing unit, I should say, and it's really there for doing tensors, doing tensor kind of arithmetic, and highly specialized hardware for doing that. And I think the neural processing unit on the Snapdragon, what is it? It's a Snapdragon 7CX, I think it is. It's rated, I think, at 29, what are called TOPS, and they are trillions of operations per second. And the whole idea behind this is, of course, we're kind of used to running some of our, particularly our AI kind of inference workloads on our CPUs or on our GPUs. But now there's a real opportunity to go and run these on NPUs. And you'll see this again. Apple are doing the same. You'll see Qualcomm are doing the same across ARM. And that's potentially going to be the way that you're going to be able to run really high performance AI models on local machines. So I kind of view it as like an intelligent edge device. In fact, in the demo that you'll find on the main page, they've got a really good photo demo, which sharpens up a photo. So it takes a blurry photo and then magically sharpens it. And it does that by running on the NPU. And so the possibilities are endless. If you think about the more we're doing, we can export an Onyx model onto the NPU and then run those workloads on the NPU. So I think that's really fascinating. Just seeing that a whole nother bit of silicon that's sitting on that die that we can actually use and start doing interesting things with.
Yes, it's amazing. CPU, GPU, NPU, all available for us in a small device, and even portable, Dave. We can take this anywhere. Like it's so small, so light that you probably can take with you. If you go somewhere.
Yeah, exactly.
I think it's smaller than a laptop. You can even put it like in a small, backpack. That's nice.
I've got my monitor that's sitting below, which is why I'm looking down a lot of the time. I have a portable monitor. You can pick those up pretty cheap nowadays too. Portable LCD, and I kind of pair that up with the device when I'm not at my main screen. So.
Yeah, because if you want to buy like a 32 gig laptop, that's going to cost you a lot of money, compare with this device. And then like to have a 32 gig for this, and you can take with you is pretty nice. Thanks a lot, Dave. I think that's it for today. I think we gave overview, and I'm expecting feedback from people watching this, and it was amazing to have recorded with you for the first time. I'm pretty sure that
it's
we're
great.
going to do
Thank
again.
you. I thought
so
we were a bit ambitious. I think we thought we were going to do it in 30 minutes. I think we're just coming out to 50 minutes. So sorry about that, folks. I think we'll stretch it on a bit longer than we anticipated.
Yeah, so but I think it was worth to get all this information, out there and showing people that they can start using that. And I think I got delivery very quick, and even because we ordered on the first day, but once they ordered, starting going through, the delivery was very fast.
Yeah.
Thank you. See you next time, everyone.
Great. Have a great weekend, everybody, depending when you're watching this.
Bye-bye.
Cheers. Bye-bye. Thanks.